This video is Unit 4 Test Review Part 3. 6th page. This is when you divide your segments into, we did triangles. What is the composite area of this figure? All right, so we have, does everyone know the formula for the area of a rectangle? Base times height, okay? And they have to be perpendicular to each other. So if you happen to have a square or rectangle, you could take that shortcut. What we taught in class is dividing it into triangles. So, of course, that's what I have to give you as an example, okay? So A, B, and C. I've got 3 regions. I'm going to add them all together when I'm done. So the area of triangle A is 1/2 base times height. Okay, so my triangle is, okay, so I know this is a right angle because this is a right angle and this is a right angle, this is a right angle. To add up, this has to be a right angle for the whole thing. So I know that one next to it is as well. And so my base and height are going to be the sides, all right? So I know my height is 13. So my base is going to be 16 minus the 8, okay? So this would be 8. Yes, you could have, but just because we are doing triangles, I'm showing you the example like that. But it's going to come out to the same answer. So you do it with the rectangle, and I'm going to do it with the triangles, and we're going to get the same answer. Okay, so my area of triangle B. Oh, I didn't figure this out. 4 times 13. I don't have that. I subtracted 8 from 16 because I knew that this was, somebody asked me on the chat, this whole side is 16 and this is 8, and so this would be the same as this. So I just wanted this part, and that's why I subtracted 8 from 16. Oh, good catch. Good catch. The height is not 13. The whole thing is 13. See that right there? So this is not 13. Let me erase. I'm glad I didn't try to do the math on that. Okay. So if this whole thing is 13 and only to here I have 7. So if 13... So this part's 7, and this part would be 13 minus 7, just 6. Okay? Everyone see that? Let me highlight that this is, that's not an eraser. So this whole thing is 13. Okay. So 1/2 times 8 is 4, times 6 is 24. And we're with centimeters squared. Remember, you do not square the number, only the units. Okay, and then now my second triangle is 1/2 base times height. And then my third triangle is also going to be 1/2 base times height. But they're going to be exactly the same because they're 2 parts of a rectangle. So we have 16 by 7. Okay, half of 16 is 8. 8 times 7 is 56. I'm doubting myself. I'm sure it is now, but I'm gonna go ahead and get out my calculator because that's what I started doing. .5 times 16 times 7 is 56, yes. All right, so we got 56 and 56. Centimeters squared, and 56 plus 24, add them all together, we get 136 centimeters, whoops, squared. Total area. Okay, any questions? Okay, let's do the last one. Again, just because I am doing this by triangles, you guys can do 10 times 8 and find out that whole thing's 80. I'm going to find out it's 40 and 40. Okay, so we have triangle A, which has a height of 6. And I know the base is the same as this base, so that's 8. Triangle, or the area of triangle B is 1/2 8 by 10. And area of triangle C is also 1/2 8 times 10. And again, you guys, you can do a square, it's just that that's just what I'm modeling because that's what we did this unit, okay? So, 4 times 6 is 24. 4 times 10 is 40. These are all meters squared. 80, 90, 104 is our total composite area. Okay, so we zoomed through that, and we still have 12 minutes or so of class. Does anybody need me to go back to anything? I added this. This is the perpendicular bisector theorem where a point is if a point is on the perpendicular bisector, then it is equidistant to the endpoints of the segment. And the converse, where if you have a point that's equidistant to the endpoints of a segment, then it is on the perpendicular bisector. This one, if you have an angle bisector, then it is equidistant to the sides of the angle. And the converse is if you have a point that is equidistant to the sides of the angle, then it's on the angle bisector.